Okay, top of the morning to you all. Or should I say good morning, good afternoon, and good evening, depending on where you are. So let's get this show on the road. I thought I would give you a little sort of status update. It's been a while, and I finally have my mic, which is cool. Finally, it just took 6 months, 7 days, and 49 seconds or something to get the hold of this. I actually bought the wrong version just to make sure I fucked it up. Anyways, I thought I would start with Amibian because obviously people have a lot of questions. You know, what is this? What can you do? How does it work? Why does it work? You know, there's a ton of those questions. So I'm going to brush over a couple of things there first now. But okay, what I've been working on lately is, of course, the messages. Because messages are, you know, the bedrock. It's the foundation for how all the different parts, you know, communicate. For example, when you start up Amibian, it's basically like a website. That website then connects to the server, obviously, and you know, just connecting isn't going to cut it. You know, you also have to be a dialogue. There has to be a login process, verification of the login. And whenever the client wants something done on the server, a message is of course sent over. It can be anything from, you know, give me a list of files that are in the home directory. I want to, you know, to read the first 1 megabyte of a file, or I want to read the whole damn thing. You know, all of these are messages that has to be sent back and forth. And one of the core problems with messages like this is, of course, JavaScript is async, which means that the moment you've sent a message, you know, you can't, you know, sit around and wait for the reply to come. There might be 100 different messages that are, you know, passing through the socket at any given point. Which is why you need a system to basically remember, okay, I sent that message, and then a reply comes back, oh yeah, that goes, you know, that's the message, or reply, that's a reply to the message that I sent, you know, 2 minutes ago or something. So that has to be taken care of. So yeah, so that's fun. And the system that you use when you create, you know, something like this is called, it's basically called a call stack. And I'm going to bring it up here so we can take a look. Call stack, oh, it's actually the one I have here. So let's have a look. Basically what you do is that you create a message and then you commit that to the call stack. And this is always done, you know, just before you send the message off. So the message is sent off, and whenever the reply comes back, the call stack is going to, you know, look it up. Okay, yeah, I sent that, you know, 4 seconds ago, or 1 second ago, or an hour ago for that matter. It will recognize it, and it will then fire off the callback method that is associated with that, you know, particular call. And then it will remove itself from the call stack, and then simply execute the callback that was, you know, set up for it. So that's how a call stack basically works. The next step, of course, was to decouple the message factory, which is just a fancy word of saying, you know, the code that creates the messages. But having those isolated in a sort of a standard class, you know, message factory, saves a lot of time. It makes it easier to expand and to make protocols based on the same system. And that is ultimately the goal here, because there's a lot of messages happening. So the first message type is between, you know, the desktop and the server. The next message type, or protocol basically, is between the hosted applications, for example, external websites, a JavaScript game, for example. How exactly is the JavaScript game going to recognize that, hey, I'm running under Amibian? Well, what happens is, after the application is loaded, the desktop will try to perform something called a handshake, which is basically sending a message, you know, give me a handshake, give me a handshake. And when the client replies with that okay, you want a handshake, here's a handshake. And when that is done and the applications, or the desktop and the application recognize each other, the desktop will basically give the application a message channel It's a special JavaScript object called the message channel. And that means that from then on, all communication with the desktop should happen on that channel, because that is a channel that goes basically directly into the heart of the system. So the desktop, whatever the application is calling, like for example, save file, for example, which is a common thing, right? You have an application, it's external, but it would like to save data on the server. So these two can be on completely different sides of the planet and still talk. So what happens is that it will send a message to the desktop. The desktop will, accept the message, and if it's not a security violation, it will delegate that message to the server. The server will do the job, send the data back to the desktop, and the desktop will then delegate that to the hosted application. So it's a pretty complex thing to make. So that's the first part, right? Or the second part. There's also another place that we need communication, and that is between the server and the child processes. Because whenever the server needs to do something, like for example scan a directory or read a part of the file, it has to be told, of course, but also it issues an external process, a secondary program on the server that is designed to do just that one thing. So it executes that, but of course they have to talk with each other. Once again, we need a protocol. So instead of me sitting here and writing basically 3 different protocols, I've created one. I've then separated all the objects. So you have message factory, you have the call stack, and also the basic message classes, which are inheritable. They're one of the benefits of Object Pascal is that you have normal linear inheritance, just like C++ would have. So you can inherit out and create new messages in 3 seconds. It's really easy to create a new message. You just inherit from those that are there. So we can set up these different protocols quite easy, right? The moment we have a system that's working, we can, okay, let's get this done. So that's basically what I've been working on now is, isolate the call stack, decouple the message factory, and, make it a sort of a portable system that can be used in many places. So we can fire this up. I have the other one, the server is now running in the back here. So you can see that it's active. And then I run a second developer environment for the client. So let's run Amibian. Just log that in. And all of this, of course, looks a bit Spartan right now. It doesn't look that exciting, but it's actually a lot of stuff, happening in the background that you can't see. So we can open this folder, for example. What happened when I double-click that is that a message is sent to the server. Give me a folder or a directory listing of the user drive, basically. I call them devices, but they're actually folders, right? But message is sent, and then a process is created, a secondary process is executed, and it enumerates all the files, creates a directory image, or basically a list of the files and directories and properties, read access, write access, all those things. And then that is delegated back to the server, and the server ships it off back to the client. So there's actually quite a lot of plumbing that's going on there. Same also when you enter a folder. When let's say we double click on an image, same thing happens. I would like to have the content of that file as a binary stream, and everything is packed and put into messages. Then it's serialized to text and sent back. It's sent in JSON format. We can change that into a binary protocol later using BSON instead of JSON. Of course, you guys haven't probably seen too much of Amibian so far, so you have no frame of reference. But this is actually pretty fast because this is running inside the VMware. Also, I'm using this is called Chromium Embedded, which is something that developers use when they want to embed a web browser in the development platform. So it's a lot slower than, for example, if I ran this directly on my desktop. But at the same time, this is a hell of a lot faster than it used to be. And now we can also start to create our own protocols with relatively ease. So let's close that down now. So it doesn't look like much, but we're actually talking thousands of files with code. There's a ton of stuff here that we have the benefit of recycling. Let's see, desktop control. So all the visual components as well are isolated in basically written from scratch. So whenever you see, for example, a content box, scrolling, a scroll box as we call it, which is basically the foundation that you see here. When I double click, you have files, and then you can move up and down. Now the movement here is going to be attached to this one, the scroll bar, but I haven't bothered to do that yet because it's really not a high priority right now. But all of this is coded, all of this it's classes. The scroll box is a class. I can clone it. Once you've written it, you can clone it 10,000 times if you want to. It has the same behavior. You can keep on working on it. So there's a lot of work going on in the background here. Let's see if I have something fun to show you here. Yeah, we have the WebSocket classes. The first version that we had was basically was written from scratch. So it's simply, it created a WebSocket server and also a client. Then I decided to decouple that as well, so that we created an HTTP server first, and then we latch WebSocket on top of that. So now I can actually pick, and I also created something called an interceptor, which is the server will now tell the difference between a message coming over through, for example, WebSocket, and a normal HTTP call, like give me this HTML file. So now the server is able to not just serve the background code and run all the tasks. It's also able to function as an HTTP server. Saves us a lot of stuff. We don't need to use Microsoft Internet Information Server or Apache or something like that. You just install it, you set up a port, and that's it. Also, the preference files are kept in ini files. A bit windowish, I know, but it's easy to parse, it's easy to work with. So if you want to change, for example, the certificates that you want to use with the server, if you're going to use SSL, you can just edit the text file and that's it. So I'm trying to stick to that as much as possible. I hate the sort of custom binary formats and all that stuff. So I really want to get rid of that. Also, I was really lucky because one of the users on Amiga Disrupt was kind enough to help me out with icons. Because reading the icon formats is really a pain in the ass. I mean, the old icon format is super simple to decode. You have fixed structures that are easy to read, but none of the new icon formats have been documented, like the OS4 format, which is the one that is most interesting, because that has 24-bit and alpha channel. So I'm going to get all the icon stuff in here as well, which is going to be really fun. Because right now the only icon system I have is basically just setting up a few known icons. So all of that is going to go away, which is going to be fantastic because I hate having hard-coded stuff. So we can have a look at, let's see what there's. We can go over to the server side, output, user data, and then in the file system, each user, whenever you register a user, he will have his own folder here. So usernames are of course restricted to what is legal to put down in the file. But I'm going to avoid the database storage thing because it will be massive, and it's just traffic that you don't really need. I mean, nothing is faster than the file system, so let's keep it simple. But okay, the preference folder. Here you will see the different, set of files. Anyone, I think everybody can understand what's going on here, right? You have a category, and then you have a name and value system. So it's very easy to edit. So you can change, the look and feel of everything using Notepad, basically. That's what I use. And then inside Amibian, of course, we will have, a visual preference window. So that's going to be good. Here's the graphic, for example, and notice that I'm using, this is running on Windows now, but I'm using the Amibian file references. So this, of course, is known as home on a Unix and Linux system. So it's basically a reference to home. Inside Amibian, that is a reference to your basically to your account drive, your user drive. So home will always point to the device you're booting from, so to speak. And you are booting from it because the moment the desktop starts and you've logged in, it will start requesting files from your file system. So if you go in here and you delete something, you screw up basically the login sequence. You also have a startup sequence that is coming in here, so you can start shell scripting. So that's cool. Let's see, themes, default. Let's see, didn't I copy in presets maybe? Nope. Okay, so I didn't copy in the files. Well, it doesn't matter. The point is that you will have all the default icon stuff that you have on the Amiga OS. So you have like default folder icon, default this, default that. We will basically mimic the same system. We will have exactly the same system. And I'm also going to try to use as many paths, so that everything is identical, or at least as similar as possible. And the icon dock is actually now loading files through the file system and asking for the preference. So the first thing that happens is that it's asking for this file, it parses it, reads the settings, for example the orientation, is the icon dock going to be on the right, on the left? Yeah. But okay, messages first, we need to do all the technical hard stuff. This is just, sort of fun weekend programming. But the other stuff, like the message factories, the protocols, that is more, it takes a bit more thinking. But once those things are in place, things is going to, change quite fast. So the desktop system itself is actually not that complicated. It's when we get down to, for example, the 68K emulation, that is going to be a little bit tougher. Also the x86 emulation. I was hoping to, push that on the server side, so that you can install Windows if you wanted, and then just run that in the window, directly through the browser. You can do that using an Apache plugin if you like, but it's a bit overkill. The whole point of this is to get away from, these hard, native coded operating systems. That's basically the clue. So that you can have, hybrid. You can write services that will execute on your account exclusively, background services, for example. You can write server systems, you can write applications for mobile phones, which is what Node Builder is all about. The idea here is that you will have a full development environment that is basically all you need is an iPad and a Bluetooth keyboard, and you can actually sit down and write a mobile application. So that's the goal, yeah. So that's going to be good. And it's actually based on reality as well. I was in Spain on a holiday, and I just, I got this $1 million idea, and just boom, out of the blue. And I immediately, got up, oh God, I have to write this down or something. And the only thing I had was my iPad. If I had my laptop with me, I would, sit down and start coding at once, just try to, get this cool idea down on paper or something, but it was lost. So when I got home, I started thinking, there has to be, maybe I can take, the desktop system I've been playing with and really turn that into a development system. So yeah, that's, I can't wait to get this finished. I love it. But okay, that was a little status for this time. Hopefully next time I will be a bit more organized with the files and stuff like that, but I just wanted to give everybody, a little heads up, and so that you can see that things are progressing. Obviously it's not as fast as I was hoping, but I got some funding. People have been really kind and support the project, and I'm really turning every penny to make this work. So I also got a server rack today, which was bought with the money from the project, which is really cool. So I can finally put those Blade servers I have to good use. So instead of hosting or spending a ton of money, hosting, and because we don't know how the traffic on this. If it's 10 users, okay. If it's 100 users, suddenly we need to scale. So it's good to have all the hardware requirements at home. So that's going to be really cool. Yeah, here you see what I was talking about. This is the protocol, the handshake actually. So you start an external program, handshake received protocol, and then it starts sending messages. This is actually a mock-up message because I'm just using a message envelope to push some data to the client. So this is a hosted application. This is an HTML5 web application which is stored elsewhere, but it's still able to talk to the desktop using messages. And the idea, of course, is to implement the exec and Intuition libraries as hopefully as close as possible, but of course there's a lot of stuff that simply isn't relevant anymore. But things like creating menu items, that is of course something that is really important for applications. Being able to, instead of having a second scroll bar, that it's able to actually set the values for this external one. So whenever you do something here, like move up and down, it will actually be reflected on the window. Changing the title of the caption of the window, moving it, full screen, all of those things. And of course the most important part, which is the file system, that external applications, music application for example, graphics application, coding, that you're actually able to save your files and they are persisted on the server. That is the most important part. So this is really shaping up, so I'm really happy about this. Okay, I'll keep you all posted. Cheers.